All right, so these are uniform motion problems with the current against the current. And what's happening is you have a boat and it's going upstream, which means the current will be going against it. So you can kind of think of the boat and the current's pushing the opposite direction. Downstream, the current's going with the boat. So if you're in this situation, the boat is slowing down. In this situation, the boat is speeding up because the current is literally pushing it. All right, so if x is the speed of the boat in calm water, and y is the speed of the stream in the calm water, then the actual effective rate of the boat would be x minus y, because the current is subtracting speed from the boat. And going downstream, the effective speed would be x plus y, because the current is actually pushing the boat. And there's your setup for the begin. Now all we have to do is go through the word problem and find out the distance traveled in each situation and the time traveled in each situation. So, when Dwayne drives his boat to work upstream, the trip takes 45 minutes. Now with rates, we want miles per hour, not miles per minute. So that 45 minutes would have to be divided by a 60 to give us 0.75. And if we plug it in a calculator, and there you go, 0.75. When he comes home downstream, it takes 30 minutes. So again, add a 60, and that's a clean division of 0.5. So now we have its hours. The distance to work is 90 miles. So whether he comes home or goes to work, the distance is 90 miles. And what we've just done now is created our formula. And it's distance equals rate times time. So for the first situation, which is upstream, we have an equation of this. And for the second equation, we have and then now we have our linear equations. And before we would actually distribute this, but since these are nice, what we're gonna do is divide them. So what's 90 divided by 0.75? 120. So we get 120 equals x minus y. And we'll do the same thing here. 90 divided by 0.5. That's 180. X plus y. And now if you notice, the y's are opposites. So we can just add them up. And we get 2x's equals 300, which would allow us to divide. So we get 150 equals x. And what x represents is the speed of the boat. It's a very, very fast boat. So the boat's speed is 150 miles per hour. And then how do we find the current speed? Just take any of the equations and plug it in. So we have 120, or we'll do the 180. So 180 equals x plus y. Plug in our x. Oops, that's the y. So that means the speed of the current is 30 miles per hour. And that's it. So that gives us an effective rate of 180 miles per hour for the boat going with the current downstream, and then going against the current would be 120 miles per hour. See? All right, let's try one more, and then I'll give you one to try. So a jet plane flying through the wind went 2,100 miles in 4 hours. Against the wind, the plane could fly only 1,760 miles per hour. Find the rate of the plane in calm air and the rate of the wind. So that's where we have the x and the y. And we always want to make x the rate of the object. So in this case, it's a plane in calm. I don't even care about the air. All right, and then the other one is just the rate of the wind. And it's the same situation. So if it goes against the wind, you would be subtracting them. And if you go with the wind, you would be adding them. Now we can fill in the rest. So a jet plane flying with the wind, that's this one, went 2,100 miles in 4 hours. Against the wind, the plane could only fly 1,760 in the same amount of time. So that gives us our two equations. 1760 equals x minus y times 4. And 2100 equals x plus y times 4. And then again, you want to divide them. So we take 1760 divided by 4, and we get 440. And then the same thing, 2100 divided by 4 is 525. And you notice the y's are nice and clean. So we get 2x equals, that's 965 divided by 2. So x equals 482.5. And what does x stand for again? It's the rate of the plane in calm air. So rate of plane in calm air is 482.5 miles per hour. Make sure there are miles here. Yep, miles per hour. And to find the rest, just plug it back in. So 525 equals 482.5 plus y. So y would equal, just subtract it, 525 minus 482.5, 42.5. So rate of wind is 42.5 miles per hour. And there you go. That's our answer. So hopefully you kind of get the idea of these systems of linear equations using currents and wind speed. Let's have you try one right here. This is for a rowing team. Hit pause and give it a shot. All right, and so this is what you should have so far. All right, let's figure it. And so here's what you should have for your answer. All right, so thank you.